Hello everybody and welcome to the Kreatryx YouTube channel. I welcome you all in a fresh session of analog electronics. And my dear friends, when I say we are going to learn analog electronics from the very basic, I mean it. We will be learning from the very basic level to the very advanced level along with a lots and lots of questions. So before we do that, let me first introduce myself for my friend who is meeting me for the first time. My dear friends, my name is Ankit Goyal. I got AIR1 twice in GATE in 2014 and 2018. I was awarded the President of India Gold Medal in the year 2013 when I graduated from IIT Indore. Till date, I have trained more than 1 lakh students in the online and the offline classes and presently working as a director at Unacademy for GATE department. But my dear friends, the reason behind this series is because of the huge demand of analog electronics and the belief that whenever you ask for anything, we are there to deliver. Yes, my dear friends, we are here for you. We are here delivering for you. And when we say it, we will support you to the very fullest level. And this series will help you crack GATE with the top rank. It will enable ECE student to get 12 out of 12 and 5 out of 5 for electrical students. So my dear friends, if you want to learn with us live, then you can join Unacademy using the code Ankit ESE to get an immediate 10% discount. And not only, my dear friend, 10% discount, it also brings you under my guidance so that I can help you do something that I have done. I can at least take you near to this goal. Okay. So if you also dream the same thing, then join me in this journey on Unacademy subscription using the code Ankit ESE. Now, my dear friend, if you like the content that I deliver, you can watch more of my free videos on this URL, tinyurl.com/AnkitESE. Here you will find all my videos arranged subject-wise, chapter-wise, and you will find great content for free. And you are definitely going to love it. You are definitely going to enjoy. It not only includes conceptual videos, but it also includes problem-solving sessions. So just visit this once and you will fall in love with this URL. Don't forget it. It is a lifeline for you. And if you love the content that we are delivering on YouTube, we have created the first ever video book for you guys, where you will find all the videos along with all the notes that we provide arranged subject wise, chapter wise. So now, my dear friends, your dreams are no longer dreams. They are becoming a reality because you are getting a top quality course, well arranged, well structured, and that too for free. So what can be better than that? What can be better than that? Nothing, my dear friends. So we have empowered the dreams of those who earlier used to think that only the person with a huge amount of money can crack GATE with a top rank. No, my dear friends, that is not the case. Even you can do. Even you can do it. But yes, just you need to believe in yourself and visit this link. But remember, this is a case sensitive link, so write this in uppercase. Other than that, if you join plus subscription, you get all the top educators like me teaching you live in daily lectures, along with providing you daily practice paper, weekly quiz, test series, previous year question, practice question, crash course, rank improvement batch, and most importantly, clearing your each and every doubt. So if you join plus subscription, it is an entire world inside it. So you don't have to look outside. Once you enter plus, every need of yours will be taken care of, and we will make your journey as smooth as possible towards that destination of getting under 100, under 10 rank. Believe me, my friend, you leave that strategy part to us. You leave the content part to us. You just work hard and we will make sure that you obtain the top rank in GATE and ESE. And Iconic is a big brother of Plus. Yes, this is a little brother. So Iconic gives you everything that a Plus subscription gives, along with much more. The major part of Iconic is this personal coach, a person dedicated to you on a daily basis to get you the top rank, guiding you, getting your schedule design, making your strategy. Everything that you need to get the top rank is being done by this personal coach. He'll also create a study planner for you, which you can follow blindly and reach your destination with utmost ease. They will be analyzing your test result and tell you where you are lacking, how you can improve. So that way, my dear friend, everybody else will get a standard analysis, but you will get an analysis just tailor-made for you. Along with it, we have included study material additionally, theory and question bank, and soon we'll be introducing interview guidance into this. So this will become a complete package for a student who wants to take that journey from being an average student to sitting into a PSU or a MTech seat. So for them, this journey will be just like driving a Lamborghini to work. So that sort of a experience, that sort of a royal experience we are going to give you. So let's move on to the lecture, and if you want to join Unacademy, just make sure you use the code Ankit ESE to get my guidance as well as to get 10% over and above whatever Unacademy offers you. So now let's move on to the lecture, dear friends, and let's see what we have in store for you.
Hi guys, in the previous few videos I have told you about how to analyze the JFET circuits. We have seen DC analysis as well as AC analysis of JFET amplifier. Now in this video we will solve some problem that have appeared in the GATE examination from JFET topic, and you can understand how to use the concept that we have learned numerically. So let us get started. In the first problem it says the JFET in the circuit shown has IDSS equal to 10 milliampere, VP equal to 5 volt. We need to find the value of resistance RS for drain current 6.4 milliampere. Okay. Now one thing that we know is in a JFET circuit, IDS is IDSS 1 minus VGS by VP whole square. Okay. Now due to this inward arrow, this JFET is a N-channel JFET. In N-channel JFET, we know that the pinch-off voltage is always negative. That means you don't have to use 5 volt, but you will have to use minus 5. The current into the gate terminal is 0 ampere. So this current is also IDS. This voltage is VGS. Now let us apply KVL in the loop at the gate terminal like this. So we will write minus VGS minus IDS into RS equal to 0. So VGS becomes minus IDS into RS. From this equation what we can do is we can substitute the value of VGS, IDSS 1 minus VGS will be minus IDS into RS by VP should be minus 5. Now it is saying that IDS is 6.4 milliampere, IDSS is 10 milliampere. 1 minus, this minus will get cancelled out, 6.4 RS by 5. Now here I am taking RS is in kilo ohm, that is why milliampere into kilo ohm will be unitless, or it will be in volt. I am just multiplying milliampere by kilovolt. So 0.64 is equal to 1 minus 6.4 RS by 5. Take square root on both the sides. It is 0.8. So 0.2 equal to 6.4 RS by 5, or RS is 1 by 6.4 kilo. 1 by 6.4 is, it is approximately 150 ohm. So that is the value of the series resistance RS, and what I have done is I have just used the current equation that we saw for the JFET circuit. Moving on. Next question, it says a JFET with the following parameter is used in a single stage common source amplifier with a load resistance 100 kilo ohm. We need to find the upper 3 dB cutoff frequency of the amplifier. What parameters are given? GM, CGD, R0, CGS and CDS. All the capacitances and transconductances given to us. Now let me draw the circuit. When we draw the circuit of the amplifier, between gate and source we will have a capacitance CGS. Then the gate to the source junction is open circuited and the voltage is VGS. Then we have a current source which is GM-VGS. In parallel to this, we have a resistance which is R0. Then between drain and source, we have a capacitance CDS. And then we will also have a load resistance RL. Okay. This source terminal will be grounded because it is common source amplifier. Now between gate and drain we have a capacitance CGD. Now we know one thing. What we know is, we know that this CGD has to be resolved into two capacitances by the use of Miller's theorem. But for Miller's theorem, we can say that the value of CGD at the input is CGD into 1 minus AV. The value of CGD at the output is CGD 1 minus 1 by AV. That means we need this voltage gain AV. AV is voltage gain without capacitor. When there is no capacitor, then the voltage gain is AV. So this is the input voltage. We can say that Vin equal to VGS. Now if there was no capacitor, then what was V0? V0 would be minus GM VGS R0 parallel RL. How I am saying this? This R0 and RL are in parallel and this current will go like this. So plus minus terminal will be opposite. So that means the voltage gain V0 by Vin will be minus GM into R0 parallel RL. Now GM is minus 2 milliampere per volt. So minus 2 into 10 to the power minus 3. R0 parallel RL 100 kilo ohm in parallel with 100 kilo ohm, that is 50 kilo ohm. So minus 50 into 2 is minus 100. Now if you calculate CGD at the output terminal, that is CGD is how much? 2 picofarad. 1 minus 1 by 100. So 1 by minus 100. So it is 1 plus 1 by 100. 1 plus 1 by 100 is 2.02 picofarad. That is the CGD at the output terminal. Now, as you can see at the input terminal, there is no resistance. If there is no resistance at the input terminal, we cannot calculate the cutoff frequency at the input. Are you getting my point? Because we know that the cutoff frequency is 1 by 2 pi RC, where R is the resistance across the capacitor. But at the input terminal there is no resistance and hence we cannot calculate the cutoff frequency at the input. So what I'll do now is I'll calculate cutoff frequency at the output 1 by 2 pi. The resistance at the output is R0 parallel RL. R0 is 100 kilo ohm and RL is also 100. So their parallel combination is 50 kilo ohm. Into capacitance, there are two capacitance CDS, and when you refer this CGD at the output, so there are two capacitance, referred capacitance of CGD and this CDS. CDS is how much? 1 picofarad. CGD referred is 2.02. So how much will this come out to be? This will come out to be 1.06 megahertz. Okay. So that will be the upper cutoff frequency of the amplifier. Is it fine? Moving on. Next question, it says a n channel JFET has saturation current 1 milliampere, Vp minus 5. We need to find maximum transconductance. Now we know that the transconductance is given as this was the expression that we studied for transconductance. From here we know that the maximum value of Gm will be equal to Gm naught, that is when VGS equal to 0. And I also told you the formula of Gm naught, it is 2 times IDSS by mod Vp. So 2 into IDSS is 2 into 1 milliampere. Okay. So IDSS is given as 1 milliampere by Vp. Vp is 5 volt. So 2 milliampere by 5, that is 0.04 millisiemens, or you can say 0.04 millimho. So that will be the maximum value of your, sorry, not 0.04, 0.4 actually. So 0.4 millisiemens, that will be the maximum value of transconductance. Okay. So you have to remember this formula for Gm naught, and that will help you while finding transconductance at any value of VGS. Next question. Two identical FET, each characterized by parameter Gm and Rd, are connected in parallel. What is the composite FET? See, when you connect two FET in parallel, let me show you how you will show the model. This voltage is VGS. Now we show a current source. This current source is Gm VGS. Rd is actually the output resistance that I represent as R0. That is also written as Rd because it is connected at the drain terminal. Okay, that is one FET. Now if you want to connect another FET in parallel, so the input terminal will be in parallel, the VGS will be same, and the output terminal should also be in parallel, Gm VGS. Okay, Rd. Then this terminal should also be in parallel. Okay, like this. So these are two FETs in parallel. Now if you see the total current that is coming here, the total current that is coming here is combination of two things, I1 and I2. That means these current sources, when they are connected in parallel, they will also get added up. So what is the net current source? The net current source is 2 times Gm VGS, or you can say for an equivalent FET, it is 2 Gm multiplied by VGS. So the overall transconductance or the net transconductance is 2 times Gm. Okay. Now these two resistances Rd and Rd are connected in parallel. So what is the net resistance? It is equal to Rd by 2. That is the net or overall value of the resistance connected across the drain to source terminal. Okay. So that I could have written directly also, because when we are connecting in parallel, the current sources will be added, and resistance we can apply the expression for parallel combination. So that I could have done directly also. Next problem. The JFET in the circuit of the figure is characterized by IDSS equal to 4 milliampere, Vp equal to -4. We need to find V0 if Vi equal to 0. Okay. So first case it is giving us Vi equal to 0. So let me redraw the circuit. This is 2 kilo ohm plus 12 volt. Then 2 kilo ohm minus 12 volt. This is V0. Okay. Now this terminal is grounded. Now what we can do is, we know the Shockley equation for the current in a JFET, which is IDSS multiplied by 1 minus VGS over Vp whole square. Okay. So if we see VGS in this circuit, this is your VGS, this is your IDS, which will go here also. So if you apply KVL like this, what you will write? Minus VGS minus IDS into 2 equal to minus 12. So VGS is 12 minus 2 times IDS. Now we know the value of VGS. What I'll do? I'll substitute here. IDS equal to IDSS means 4 milliampere. 1 minus VGS 12 minus 2 IDS. IDS I am taking in milliampere by VP minus 4. That is 4 milliampere. 12 by minus 4 is minus 3. So 4. Then minus IDS by 2 whole square. So this will give us a IDS equation, quadratic equation. Now if you solve, you will get the two values of IDS. One value will be 11.3 milliampere and the second value is 5.62 milliampere. So we will get two values of IDS. One is 11.3 and other is 5.62. Now how to decide which value you have to take? You have to check VGS 12 minus 2 IDS. For the first case, when IDS is minus 11.3, VGS is how much? 12 minus, then it is 22.6, that is minus 10.6, which is less than VP. So it is not possible. Okay, sorry. VGS is negative. Let us try another case also. The next case is when IDS equal to 5.62. So what is VGS in this case? 12 minus 2 into 5.62. So it is 11.2.8. Now this is positive, but VGS must always be less than 0. Are you getting my point? Because in JFET we always use negative value of VGS in order to increase the depletion width. So what value I will choose? I will choose 11.3 milliampere. Now how to find the value of V0? In this case, V0 is simply minus VGS, that is equal to 10.6 volt. So V0 will be 10.6 volt simply as minus VGS. So that will be the answer. Is it fine? So let us try the second part. In the second part it says find Vi if V0 equal to 0. In the next case we have to find the input voltage when V0 equal to 0. So let me draw the circuit again. This is 12 volt, 2 kilo ohm. Minus 12 volt, and let me show that the voltage here is simply Vi. Now this voltage V0, this is equal to 0. This voltage is VGS. Simply by KVL you can say VGS is Vi minus V0, which is equal to Vi. Okay. So now VGS is equal to Vi. What more I can do is I can find out the drain to source current. IDS equal to IDSS 1 minus VGS by VP square. Okay. Now how to find IDS? See, the current in this resistor will be IDS. Just apply KVL like this. V0 equal to minus 12 plus 2 times IDS. This must be 0. So IDS will come out to be 6 milliampere. Why is this 0? Because V0 is given as 0. So 6 milliampere equal to 4 milliampere 1 minus input voltage by pinch off voltage. Pinch off voltage is minus 4. So it will become 3 by 2 equal to 1 plus Vi by 4 whole square. From here you can calculate the value of Vi. Okay. So how you will calculate the value of Vi? By taking the square root, you will get two values. The two values will be minus 8.898 or 8.89. But we know that VGS is equal to Vi. It should always be negative. So we will say that the input voltage is minus 8.89 volt. Because it must always be negative. Is it fine? For N channel JFET, VGS is always negative. For P channel JFET, it is always positive. So the answer will be minus 8.89 volt. Next problem. A N channel JFET has IDSS equal to 2 milliampere, VP equal to minus 4. We need to find transconductance for VGS equal to minus 2. Now I have told you the formula for transconductance. GM equal to GM naught 1 minus VGS by VP. This GM naught is the maximum value of transconductance 2 times IDSS by mod VP. IDSS is 2 milliampere by 4. So that is 1 millisiemens. So GM will be 1 millisiemens. 1 minus VGS. VGS is minus 2 by VP is minus 4. So that is 0.5 millisiemens. Okay. So that will be the answer. This unit is wrong. It should be mho or Siemens. So millisiemens, the answer will be 0.5. Next problem. A JFET having mu equal to 50, RD equal to 10 kilo ohm is used in a common source configuration. We know the JFET capacitances. We need to find the midband voltage gain and the upper minus 3 dB frequency. Now this mu, what is this mu actually? This mu is nothing but mu is plus GM into RD. Mu is always GM into RD. RD is this resistance. Okay. So now, how you can find out the value of the midband voltage gain? For that, what we need to do is, we need to design the AC model. Okay. So how you will design the AC model? First you will take Vs. First I am designing only for midband gain. Because when we talk about midband gain, we will not use any capacitances. This is RS. The gate to source is open with a voltage VGS. Now the source terminal is grounded. Between drain and source we will have a current source GM VGS. In parallel to this we will have output resistance, which in JFET is written as small rd. This rd is actually R0. Then this VDD will be grounded. If you ground this VDD, this capital RD will be connected between drain and ground. Okay. So now this is your V0. What you can say, V0 is minus GM VGS R0 parallel RD, or you can say minus GM R0 RD by R0 plus RD into VGS. But we need the voltage gain V0 by Vs. If you see this circuit or if you see this loop, due to open circuit there is zero current here, which means there is no voltage drop, and you can say VGS equal to Vs. So minus Gm R0 Rd by R0 plus Rd into Vs. That means the voltage gain V0 by Vs minus Gm into Rd is mu. So minus mu R0 by R0 plus Rd. If you substitute the value, mu is given as 50, Rd is given as, this is actually Rd, so small Rd everywhere. Okay, mu is 50, Rd is 10 kilo ohm and Rd plus capital Rd 20. So it is minus 25. So that will be the mid-band voltage gain. Now for upper cutoff frequency, what we'll do? We will design the AC model, but now including the capacitances. This is Vs. This is Rs. Now between gate and source, we will have a capacitance CGS, and the gate to source terminal will have a voltage VGS. Then there will be a current source GM VGS between drain and source, and the source terminal was grounded. This current source will be connected in parallel to a resistance R0, or you can say small Rd, and there is a capacitance also between drain and source, which is CDS. The drain terminal is grounded with the resistance capital Rd. Also between gate and drain, we have one more capacitance, that is equal to CGD. Now we know for upper cutoff frequency, we have to refer this CGD to the input as well as to the output. Now what is the value of CGD at the input? It is CGD into 1 minus voltage gain. What is this CGD? CGD is 2 picofarad. 2 into 1 minus AV. AV I calculated just now, minus 25. So it is 52 picofarad. What about CGD at the output? It is CGD 1 minus 1 by AV. So 2 into 1 minus 1 by minus 25. 2.08 picofarad. That means this CGD is now resolved into two capacitances, one at the input and one at the output. So the output capacitance now becomes CDS plus CGDO, CGS plus CGDI. Now you can calculate two upper cutoff frequency, one at the input. At the input, what is the resistance? Rs. So 1 by 2 pi. Rs is how much? Rs is given as 2 kilo ohm, and input capacitance includes CGS 5 picofarad and CGDI. So 2 kilo ohm into CGS is 5 picofarad plus 52. That is 2 kilo ohm into 57 picofarad. So that will come out to be 1.39 megahertz. What about the upper cutoff frequency at the output? 1 by 2 pi. What is the resistance at the output? Small Rd in parallel with capital Rd into C0. The small Rd in parallel with capital Rd will become 5 kilo ohm. What will be the capacitance? CDS is 2 picofarad plus output capacitance, that is 4.08. So this frequency will come out to be how much? 7.95 megahertz. Now we know the upper cutoff frequency is always taken as minimum of input and the output cutoff frequency. So it will be 1.39 megahertz. Okay. So that is how you have to calculate the overall value of the upper cutoff frequency. Moving on to the next problem, it says the voltage gain AV V0 by Vi of the JFET amplifier shown in the figure is, we know IDSS as well as Vp. But before finding the voltage gain, we will have to perform the DC analysis in order to compute the transconductance. and for that purpose only it has given us IDSS and VP. So how we will do it? First we will open circuit this capacitor. Now this voltage is VGS, this current is 0. If this current is 0, this current will also be 0. This current would be, this capacitor will be open, this current would be suppose ID. Let us apply KVL. So what I'll say, 0 minus VGS minus ID into RS equal to 0. So VGS is equal to minus ID into RS. Now we know ID is also equal to IDSS 1 minus VGS by VP whole square. Now this ID is equal to IDSS, which is 10 milliampere, 1 minus VGS. So minus ID into 2.5 by VP. VP is minus 5. Okay. So this will be ID equal to 10 milliampere, 1 minus ID by 2 whole square. Now from here we can calculate the two value of ID by solving the quadratic equation. Okay. So what are the two values of ID? So first we will form quadratic equation. ID 10, 1 plus ID square by 4 minus ID. So that means 2.5 ID square minus 11 ID plus 10 equal to 0. Now this is a quadratic equation. Either you have to solve it manually, okay, otherwise you can also put it in the calculator. But since now virtual calculator is only used in GATE exam, you have to solve it manually. So what you will write? ID will be 11 plus minus B square minus 4AC. So B square is 121, 4AC. 40 into 25 is 100 by 5. So it will be 11 plus minus root 21 by 5. So 11 plus under root 21 divided by 5 is equal to 3.11. The other value 11 minus root 21 divided by 5 is 1.283. So these are the two values of the drain to source current. Now we need to find the value of VGS. If you calculate VGS, it is minus ID into RS, which is 2.5. So 3.11 into 2.5 will come out to be 7.775. And for the second value 1.283 into 2.5, it will come out to be 3.2075. So we have two values of VGS. Which value we have to use, that we have to consider here. Okay. So which value we will use? We will use this value minus 3.2075. Okay. Because it is less than VP. So once we know the value of VGS, we will first calculate GM naught, which is 2 IDSS by mod VP. So 2 into 10 by 5, that is 4 milliampere per volt. That is GM naught. From here you can calculate the value of GM. So how you will calculate the value of GM? One thing that I have missed in this problem actually is, we did not need to do so many things. Why? Because we have overlooked one important thing in this problem. It has given us ID. Okay. So that means I'll use this value of ID which it has given us. So I'll say GM is GM naught under root ID by IDSS. So 4 under root 1 milliampere by 10 milliampere. Okay. So how much will this value come out to be? 4 divided by under root 10. 1.2649. But there could be other method also to calculate GM. Just now we wrote VGS was minus ID into RS. So VGS will come out to be how much? ID is 1 milliampere. 1 into RS, that is minus 2.5. So GM can also be written in another manner. So GM naught is 4. 1 minus 2.5 by minus 5. So that is how much? 2 milliampere per volt. That means both the equations are giving different values of GM. So how to decide which value is correct? Basically, this question has a flaw that we don't get the same value of GM. So the data given in this question is not completely correct. Why? Because we just now derived the value of drain current and it did not come out to be 1 milliampere. I told you using the DC analysis we derived the value of ID, but it was not coming out to be 1 milliampere. That is why the data given is not correct. But still, suppose I use the second value of GM, what would be my next step? My next step would be to design the AC circuit. So capacitor will be shorted. We have a resistance RG here. Then between gate and source we will show a voltage VGS. Okay. Now due to this CS capacitor, CS will be shorted, the source terminal will be grounded. Then we will show a current source GM VGS. Then we will have a output resistance R0, or we can write it also in JFET as RD. After that, if you see, the drain terminal will be grounded with the help of this capital RD. The drain terminal is grounded with the help of capital RD, and this drain terminal is connected to V0. Now since small rd is not given, what we will do is we will consider that it tends to infinity. In such a case, it will be open circuited. If it is open circuited, then this GM VGS current will flow like this, plus minus will be like this. So what you will write, V0 will be minus GM VGS into capital RD. And what about Vs or Vin? Vin is actually equal to VGS. So if you calculate V0 by Vin, it is minus GM into RD. GM, if I take it as 2, RD is given as how much? 3 kilo ohm. So it will come out to be minus 6. So the voltage gain will come out to be minus 6, and that will be the answer. But remember, the data given in this problem is not completely correct, because the given value of drain current and the calculated value are not equal. Okay, so that is how the kind of problems that can be asked in JFET. There are 3 types of problem: biasing, voltage gain, and the upper cutoff frequency. These 3 kind of problems can be asked. Okay, so this is all from this video, and these are the problems that can be asked. Thank you.
I hope all of you have enjoyed the lecture that we were providing, and all of you learned something very good. Now is the time to learn about the Unacademy subscription. So as I told the benefits of the Plus subscription at the very beginning, let's go through them very quickly. Live classes you get by the top educators, crash course, rank improvement batch, doubt clearing, weekly quiz, test series, previous year question, practice question, everything in one subscription called as Unacademy Plus. And iconic is one level higher. It provides you a personal coach who will mentor you on a daily basis, who will guide you on a daily basis, along with providing you study planner, test analysis, study material, and soon enough interview guidance. So if you are looking to join Unacademy, let's see what are the pricing. So my dear friends, Before we see the pricing, just see the link. This link will help you crack GATE and ESE with the top rank because we have created the first ever video book for GATE and ESE for my YouTube family, and you will get the notes as well as the lectures here. Just make sure that you write this link in the uppercase and you will get to the first ever video book for GATE and ESE, and it is nothing but revolutionary. Now let's see the pricing of Plus subscription. So for 12 months the pricing is 3250, but if you apply the code Ankit ESE it becomes 27225. For 18 months it will be 34650, and for 24 months 39600. Believe me my dear friend, this is the most affordable pricing, and the longer duration subscriptions are more cost effective as compared to shorter duration. Like here it will cost you 1650 per month. Okay, this will be 2000 per month approx. This will be around 2250 per month. Then if you go for Iconic for 12 months, it is 5250. With code Ankit ESE it becomes 45225, and 2-year subscription becomes 66600. So the choice is yours, but take a longer duration subscription for more cost effective solution and to give GATE and ESE at least 2 times, so that if you once crack GATE, in the next attempt you can even get ESE. And other than that my friends, you can download the Unacademy learning app right now, because there we provide live classes for free, test series and live quizzes for free. And once you download it, make sure that you follow this profile. This is my profile, so that whenever I come live you will get the notification. And this is the Telegram channel for our team. Here you will find all the lecture links, all the lecture files, and all the links for the special classes. Other than that my friend, my personal Telegram channel also you can join, t.me/gateair1. Here you can get in touch with me and we can take this journey together. Okay. Other than that, we have other YouTube channels like Mechanical, Civil and Telugu, JEE channel, Computer Science, Gate Question and Electrical Junction, Pathshala and GS Terminal. Electrical Junction contains short videos of great concepts. Pathshala provides you animated content. JEE preparation can be done through these 2 channels, Unacademy SSC JEE and GS Terminal. And you can refer the other channels to the other friends in respective branches so that they can also be benefited. At last, I would like to say, please share, like and subscribe to this channel. Subscribe to this channel, and not only subscribe, press the bell icon so that you get notified whenever a new video comes. And share these videos among all your college group, among all your friends, so that we can create the first ever revolution of free education in field of GATE and ESE. Thank you to everybody for dedicating time to watching this video. Please move on to the next one as well and take the benefit of all the free content that we are providing. And in case you have completed the series, do make sure you watch the other subjects available on this channel. Thank you.